Solving application problems with geometric sequences. In real-world scenarios involving arithmetic sequences, we may need to use an initial term of a subscript 0 instead of a subscript 1. In these problems, we can alter the explicit formula slightly by using the following formula. A subscript n is going to equal the initial term a subscript 0 times the common ratio r raised to the power of n. So for example 6, we're solving application problems with geometric sequences. In 2013, the number of students in a small school is 284. It is estimated that the student population will increase by 4% each year. In part A, we want to write a formula for the student population. Now, the situation can be modeled by a geometric sequence with an initial term of 284. Now, the student population will be 104% of the prior year because it's increasing 4% of the 100. So the common ratio in decimal form is 1.04. So we're going to let P be the student population, and we're going to let N be the number of years after 2013. So we know that the first term in this case, or the initial term, is 284. And we determined that the common ratio is 1.04. So it's going to be 284 times 1.04 to the nth power. And now what we're going to do is we're going to estimate the student population in 2020. So in part 1, we can find the number of years since 2013 by subtracting 2020 minus 2013, which gives us 7. So we want to be able to find out P of when n is equal to 7. So we're going to plug n to be 7. So on our calculator, what we're going to do is we're going to take 1.04 and then we're going to raise it to the power of 7 first because you're going to do order of operations. And then we're going to take that number and then we're going to multiply it by 284. And that's going to give us approximately, if we round this to the nearest number, 374. So, in step 3, the student population will be approximately 374 in 2020.